Talk to you today about emotion estimation in my research that I'm currently working on, starting with the concept of emotion estimation. For humans, it happens usually by so many methods, such as understanding language or voice tone or facial expressions and body posture too. Could be interpreted to understand what the emotion of the person. So my research is focused on computer vision and the facial expressions and how the changes and flex of facial muscles could communicate the emotion of the human. Next slide, please. The use case of this research or model to be implemented on social robots that would be used in social robotics and elderly care and patient care, which will be functioning as a feedback system to the robot to be able to understand the person that it is interacting with, whether they are liking the conversation, the activities that the robot is doing or not, and be able to react or change the course of the conversation in a favorable way. And next, please. And starting with this research, you will be using the affective in the wild dataset. But before that, I want to touch on the proof of concept for this research, where built the smaller model using the FER 2013 dataset to classify the emotions of happiness, sadness, and all the others are in only 3 classes. That model was a bit limited in capabilities, but still delivered some results that we'll be discussing in next currently planning to work on the bigger dataset, which will be in RGB images and for more than 500 videos, split into frames, around 2.8 million frames, and using 3 types of labels, which is for classification of 8 emotions, 12 action units, and valence and arousal. Next slide, please. Starting with the research, feature extraction will be using probably such like the proof of concept, where use the media pipe library to extract landmarks, facial landmarks, and maybe as in the proof of concept using the blend shapes, which is a 25 probabilities for the blend shapes of the face, which shows the one side or part of the face and a certain expressions that being displayed on that part. While the landmarks are, there are many of them that get estimated by MediaPipe, and according to the position of the landmark or the distance between one another, could understand the expression that is being displayed on the face that is being displayed in the camera feed or the image. Next one, please. The proof of concept results was as shown in the confusion matrix and the F1 score and the accuracy numbers that we reached in the work. And the model was a simple one, only 4 layers of LSTM with a classification capabilities, was trained on the grayscale dataset, and there was in the previous slide the link in the bottom of the slide for the demo video and the results that we've reached in the research. So hopefully we'll be looking for a bigger and more capable model. And next slide, please. and still really choosing which model. So if anyone interested, please contact me on Discord or DM me to further research in this research and maybe choose the architecture and further steps for the model and how to build it. Thank you so much.
Thank you, Samer. Question here from Ahmed. Is the model and dataset open source? And what is the latency?
The dataset, yes, of course, open source. The model, it was open source, but currently I did close it to improve the code, the structure of the repository, and there's the paper and the documents that is made for it also will be disclosed in coming months. And the latency didn't really measure it because there wasn't any implementation, so didn't work on the measuring the inference time, but the concept of estimating the emotion was proved successful in the proof of concept stage, so took it further to the improve the model, and will be optimizing, of course, for the latency in the next steps of the full model.
Excellent.